All right, students, so we're here with circumcenters, perpendicular bisectors of triangles. And this next few lessons I really like. I actually find very interesting and they're pretty cool. So put on your thinking caps and let's go. Given the segment, find and label the midpoint. All right, so we got this point is at 3, -3. This point is at -5, 1. All right, now we have the midpoint formula, but let's just count the midpoint. All right, how far do we go down? We go down 4/8. Well, if we want the midpoint, let's just count down 2/4. So instead of going down 4/8, we went down 2/4, and boom, right there. We just used a little logic to find the midpoint at -1, -1. All right, and we'll call the midpoint capital M. What is the slope of the segment? All right, well, we just counted. It was down 4/8, which reduces to -1/2. All right, so we're gonna write and graph the equation of the line that is perpendicular and passes through the midpoint of the given line. All right, so, well, we need to be perpendicular to this green line. Well, my new slope, remember, perpendicular, you're going to change sign and flip. We need an opposite reciprocal. So now I'm going to have positive because I'm going to take 1/2, it makes it positive, and then flip it 2/1. So positive 2/1 just simply can be wrote 2. So from this midpoint, boom, at this midpoint I'm going to go up 2/1. And just to help me kind of, actually no, never mind. I'll make a line that goes through. Wow, pretty. All right, so this blue line, this green line, they are perpendicular. And this blue line bisects this green line right here. It's a perpendicular bisector, and it's actually pretty important in math. Right angles are very important. To be halfway between 2 points is very important. But it also said write an equation, so let's go ahead and write y equals mx plus b. Just a quick review from last year. Well, we already said the slope was x, and the b is the y-intercept, which is right there, boom, 1. All right, so that's pretty cool. We wrote an equation, y equals 2x plus 1. That was the perpendicular bisector of that green segment. Can you guys feel the power of geometry flowing through your veins right now? You guys are getting very good at math. All right, now, reading this next part. If we are really, truly good at math, now if we are good at math, the point 1,3 should fall on our perpendicular bisector. Look, 1,3, boom, right there. Yes, we are good at math. All right, we're gonna find the distance from 1,3 to both of the endpoints. So what's it saying is that I wanna do this. I wanna find this distance, and remember this was 1,3, and then that distance as well, all right? We're gonna find these two pink distances, and we have the distance formula. We practiced that a billion times lately. Let's use the Pythagorean theorem shortcut. All right. We got a squared plus b squared equals c squared. This side length is 2. This side length is 6, as is expected, and we'll call that c. So remember, Pythagorean theorem, a squared plus b squared equals c squared. I like to write it, though, as c squared equals a squared plus b squared y. That's just the way I am. All right, a was 2, b was 6. It doesn't matter which one's a and which one's b. It just it's just important that we keep c separated. And then take the square root of both sides, and c is going to equal the square root of 40. I'm just going to keep it like that. All right, next. We got this one over here, 1, 2, 3, 4, 5, 6. Well, 6 and 2. Well, so we can kind of see that. Well, again, we're going to have c squared equals a squared plus b squared. We're going to have c squared equals 2 squared plus 6 squared. So it turns out that the other c, I should have used a different letter, but oh well, will be the square root of 40. So this is kind of interesting. What is interesting, you ask? Well, this exactly right here. This point is on the perpendicular bisector, and it's equidistant from the endpoints. Wow. So on the perpendicular bisector, any point on the perpendicular bisector is equidistant to the endpoints of the segment. All right, and that's actually the perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, then it is equidistant. And sometimes students ask me, what does equidistant mean? It's kind of a self-explanatory word. It means equal distance to the endpoints of a segment. So it says draw a picture below. We'll draw it like this. We'll keep it simple. All right, so this orange line is perpendicular to this brown line, and it bisects it, so it's saying that's the midpoint. And it says I can pick any point on this orange line, but if I connect any point on this orange line, it's going to be equidistant to the endpoints. That's what it's saying right there. All right, and this kind of sounds like, why do I need to know this? It's a little boring at first, and we're going to do some algebra problems. This is kind of the warm-up. Like, I like to call this Attack of the Clones, that Star Wars movie's Attack of the Clones guided notes. The movie starts out really boring, but by the end it's really cool. These notes are a little bit boring at first, but by the end they're really cool. All right, find the value of x and the lengths of wz and wy to the figure on the right. All right, so what this is saying basically is, look at this. All right, this purple line bisects this purple line, or it's a perpendicular bisector. All right, since w is on that line, it means that 2x plus 11 and 4x minus 5, those lengths are equidistant. All right, so they're just going to be equal to each other. So when in doubt, when you see some crazy geometry problems like this, when in doubt, just start setting things equal to each other and see what happens. All right, we're going to get 11 equals 2x minus 5. I'm going to add 5 to both sides. We're going to get 16 equals 2x. Divide both sides by 2. 8 equals x. Smiley face. All right, so that's just kind of emphasizing how any point on the perpendicular bisector is equidistant to the endpoint. All right, number 3, OQ is the perpendicular bisector of MP. All right, so it's saying, just to emphasize things, this is a segment. This is the perpendicular bisector. It shows that it's perpendicular, but that means those two segments will be congruent. All right, which segments in the figure are equal? Well, I just wrote out one, so I'll write A over here. This is the answer to A. Well, MO and MP are. Well, and then clearly LM and LP are, they're both 15. And then lastly, well, since Q is on the perpendicular bisector, that means it's equidistant to the endpoint. So that means MQ is equal to PQ. All right, so that's the answer to A. And that's kind of nice because that brings us to B. It says find the value of x. Well, it's just going to be 11 equals 4x plus 3. Subtract 3 from both sides. 8 equals 4x divided by 4. And 2 equals x. And then the last one, C. It's saying, is L on OQ? The answer is yes. How do I know? Well, OQ goes forever. It's a line. That's why we have the arrows. How do I know that it will exactly hit L? Well, it's because L is equidistant from the endpoint. So it's the converse of the perpendicular bisector theorem. Converse of the bisector theorem. All right, and that's that for this notes. Stay tuned for the exciting parts. Wow.